Hi all, and welcome to this episode of Learn Kubernetes with Google. Today we're talking about multi-cluster service networking. My name is Laura, and I'm a software engineer working on Managed Multi-Cluster at Google. And for this series, I'm joined by my friend Sanjeev Rampal, Principal Engineer at Red Hat. How's it going, Sanjeev?
Hey Laura, great to join you on this really fun topic.
Yeah, I'm super happy that we could work together on this series because we want to talk about a lot of different projects and try and give you, the viewers, some tools to make decisions on how to set up your multi-cluster setup. But it's a really big question to answer. And so I'm really glad we could work on it together. I was really confused myself when I first learned about all the different options.
Exactly. There's a lot of very interesting and very cool projects in this space, but sometimes they overlap and it's hard to figure out how you can use these in combination or separately. So hopefully the discussion we have, Laura, will provide some analysis and bring some clarity to the space.
Awesome. Well, let's get to it. So first, let me just go over what we're going to talk about in this episode. So first, we're going to introduce the concepts first, that basically what is multi-cluster service networking. And we're going to talk about some big picture layouts and also some terminology and lingo, make sure we're all on the same page. And then we're going to introduce several different multi-cluster service networking projects, including kind of the general categories that they fit into. And then we're going to compare these existing multi-cluster service networking projects to each other and consider from both an admin perspective and a developer perspective, what is the decision-making process for which of these projects that you want to use when what you want to do is to stitch your applications together across multiple clusters. So let's go ahead and tackle that first bullet point there. On this slide and the next slide, we're going to make sure we're all on the same page on the big picture and some terminology like network, gateway, cluster set and mesh, and also multi-mesh. So we're talking about multi-cluster, right? So we have this iconography here, also on the bottom left here, about an individual cluster with an embedded gateway. So whatever that gateway actually is itself, what it's representing is whatever networking infrastructure is needed for these clusters to actually communicate with each other, even if they're hosted on different networks. So for example, you can see over here, we have some clusters with embedded gateways that are in network N1, this orange brown bubble here. Over here, we have some clusters in network N2, this green bubble. But they are able to communicate with each other, and as a whole, they're interpreted as one cluster set or mesh. So each of these gray bubbles is one unit of being either cluster set or mesh, and those are semi-interchangeable terms. It just depends what multi-cluster service networking solution that you're using. And the gray bubbles themselves are kind of the logical limit of clusters that are sharing services with each other. And you'll see that we have three such bubbles on this diagram, one over here, cluster set mesh A, but these other two here, which are referred to as external meshes, external mesh B or external mesh C. And this is to get across the idea that there might be multiple meshes and that potentially people will want to communicate across meshes. So this is what that term multi-mesh means, where you have a topology of many clusters within a cluster set or a mesh, many clusters in another cluster set or mesh, and they might also need to communicate with each other. So besides just the lingo, part of this slide is to make sure we're on the same page for this episode, that the projects we're talking about are within one of these mesh or cluster set bubbles, within one of these gray bubbles. So all the solutions we're talking about are not really providing abstractions that simplify the multi-mesh case, but are about making it easier to do multi-cluster service networking within a single cluster set or mesh. So I am going to hand it over to Sanjeev to look at the next slide, which is going to take a more detailed zoom in on a single mesh or cluster set.
Thanks, Laura. Yes, hopefully we might get a chance to look at multi-mesh in future episodes. So let's look further into a single cluster set here. This diagram shows four clusters that belong to a single cluster set or mesh. And this topology might be described as multi-network, multi-cluster. It is multi-network because, as you can see, there are two networks here. Cluster 1 and cluster 2 run on network 1, and cluster 3 and cluster 4 run on network 2, while all of these are part of the same cluster set or mesh. Being a long-time networking person, at this point, I usually try to clarify that terms like network and gateway are used in a slightly different context, Laura, in the service networking space than in the traditional IP networking space. So, for instance, in the traditional IP networking space, a network is essentially an IP subnet. A gateway is essentially an IP router that interconnects IP subnets. Here, in these projects, the term network typically refers to a single routing domain, okay, where all the endpoints have unique IP addresses and can directly send traffic to each other without needing to go through any kind of NAT or address translation operation. There might actually be several IP subnets or IP routers within a single service network, but we are sort of looking at the service network layer, and that's what we refer to here as a single network. So in this diagram, for example, cluster 1 and cluster 2 are on the same network, which means pods in cluster 1 and in cluster 2 have all unique IP addresses, and a pod in cluster 1 can directly talk to a pod or service in cluster 2 without needing to go through any kind of gateway. Whereas if a pod or service in cluster 1 needs to talk to a pod or service in cluster 3 or 4, it does need to go through some kind of gateway, because these are on different networks. And in this picture, we show the MCS gateway 1 and 2 as potential gateway devices that implement the multi-cluster services API that we'll be talking about more in future. And that allows this cluster set to work across networks. Finally, we also show that there are multiple kinds of gateways. Here we see there's an ingress gateway, which is a gateway used to bring traffic into this cluster set or mesh. In this particular picture, it happens to be a multi-cluster gateway that is actually running off cluster. And we'll get a chance to talk about the different kinds of gateways. And there's also an egress gateway. And finally, as we said earlier, there's also the multi-cluster services gateway. So hopefully this gives a little bit of a pictorial representation. And let's move on to the next slide to get into more details. So as Laura and I were sort of thinking about this space and all the different projects, we wanted to categorize these into buckets. And we concluded that maybe 3 buckets sort of make sense. And those are shown in the colored bubbles here. So on the green bubble on the top left is the category of projects that we normally refer to as regular service meshes. Projects like Istio, Glue, Linkerd, and many more. These are fairly sophisticated application networking projects, and we'll be getting in more into these. On the top right, we have the orange bubble, which we're referring to as the Kubernetes native multi-cluster mesh technologies. Here, the projects leverage the fact that Kubernetes itself is essentially a service networking technology. There are services, you can have pods to services and various kinds of service discovery features. So why not extend Kubernetes in the multi-cluster space? And that's what projects like the Kubernetes Multi-Cluster Services API, the Kubernetes Gateway API are doing. And there are various implementations like Submariner and GKE MCS that are implementations of these. So that's the bucket number 2. And on the bottom left is a bucket that we're calling virtual application networks, which are a set of overlay networking and overlay application networking projects. The primary example of that is a project called Scupper. And the emphasis here is on ways to create application networking topologies and meshes completely over the top of any cloud and admin provided infrastructure. So we figured these are 3 reasonable categories into which to classify these technologies. On the bottom right, we've just shown for completeness that there's also the entire conventional networking layer, which we will be not covering in this series, even though that's a very important part of the overall solution. So Laura, what do you think about these 3 buckets and categorizing these different technologies?
Yeah, so I think a lot of our viewers might be familiar with, or at least have heard of some of these technologies in the service meshes category. And I think that that has, historically, as long as the history of multi-cluster has been, which is itself relatively short, have been sort of the primary solutions in. And I really want to highlight that the Kubernetes native multi-cluster mesh technologies are really emerging and are also quite different from the service meshes in one key component, which its name indicates, that they're these Kubernetes native APIs, these APIs that are kind of built around extending maybe the service API or extending APIs that are already in Kubernetes, and making the experience feel very close to that. Whereas historically, the service meshes implement another API layer on top of your Kubernetes API or other compute that you're using that your service mesh can also work on top of. And that's means by which they can also provide much more configuration, many more features, and work against many different types of backends. But that's one really big distinction I feel between the service meshes, which have historically been a big part of this space, and the emerging Kubernetes native multi-cluster mesh technologies.
Exactly, and I think as we evolve, we can see a lot of cross pollination of ideas and even usages
Totally,
of across these projects. Let's
totally.
move on to the next slide. So, as we wanted to, create some sort of taxonomy or ability to distinguish between these projects, our first pass was look at the two dimensions, right? So, in this picture, the x-axis is the dimension of the deployment persona, right? Which persona, whether the cluster admin or the developer or namespace admin, that particular set of projects is primarily focused on or requires, those kinds of privileges. And on the y-axis, the dimension is about whether that project deals with a pod-to-pod level end-to-end networking, or which is on the top of the y-axis, and towards the bottom is technologies that are cluster to cluster or service to service. So here we see that the service meshes fall into the cluster admin space because they typically require admin privileges to deploy. But once the admin has provided that as a service, then application users can create virtual services and things like that to take advantage of the admin provided service mesh. And also, these are technologies that go all the way up to the pod for encryption and networking. So these are essentially pod level networking technologies. On the orange bubble, we have projects like Submariner and GKE, which are perhaps closer to being service to service networking technologies, and hence their position on the y axis. And also, they have a mix of cluster admin functionalities, such as creating cluster sets, and namespace user technologies, such as providing service exports and imports, all of which we'll discuss more in the future talks. And then finally, on the right side, we have the virtual application network projects, which clearly fall completely in the developer and namespace admin persona. Also, from the end-to-end networking scope, these typically they typically perform namespace to namespace level networking. So they're somewhat in between the full service mesh and the K8s native service mesh. Laura, what do you think about this sort of initial categorization?
Yeah, so I think this initial categorization is really helpful to kind of see where these projects sit on these two dimensions, which are really a critical first pass to be thinking about where these technologies sit. But they're actually, how we even backed into this was that there's a ton of factors that go into this decision. And actually, I'm going to take us on the next couple of slides just to kind of take us through what that type of decision making process might look like, and some other ways that we can sort of map these categories of technologies against each other. So I've got a couple slides here to kind of take it from the perspective of, if you're thinking through either you're a cluster platform admin or you're a developer or on app ops, what are the types of things that you're thinking about when you're trying to decide which of these at least categories of technologies you want to be pursuing for as a solution for multi-cluster service networking? So, one direction that this may come is if you're asking yourself, are there just a few services you need to string together, or many of them, but you don't have a lot of time to set up more infra? Um, can you accept pretty basic ingress traffic routing like route weights instead of anything really specific about traffic shaping? Do you not need MTLS pod to pod, or do you need it only for a really small set of workloads? So it would be okay for you to configure it yourself. And do you not need a different solution or an all encompassing solution for cert management? This is the type of thought process that might lead you to the Kubernetes native multi cluster mesh technologies, which can give you the ability to string these services together across clusters with a couple of traffic routing features, but not like a really sophisticated set of traffic routing or pod to pod MTLS type solutions. So, one way that we could kind of go through this little conversation, right, is if someone was asking themselves, can I use Kubernetes native APIs? Can I use these Kubernetes native multi cluster service technologies? One sort of thought process they could be going through is, well, I just need to string a few services together or many of them, but I don't have time to set up a whole new infrastructure stack. If you're okay with basic ingress traffic routing, like route weights, and you don't need MTLS pod to pod, or you only need it for a small subset of workloads, so it would be okay for you to configure it yourself. And you're not looking for a one stop shop for your cert management, then you might be in the category of these Kubernetes native multi-cluster mesh technologies because they can address all the things that you need, and you can get this service discovery across your clusters using those technologies. But another little thought bubble that our little red character down here is asking themselves, do I need a service mesh? The type of questions you might have running through your brain at that point is if you do need more security pod to pod for most or all of your workloads, which would be very tedious for you to configure on your own. It would be better if your solution could handle this. Or you need really sophisticated traffic routing. Some of the types of features in this category might be locality load balancing, which becomes more relevant if you have many clusters in different regions, or rate limiting, something rate limiting that you could configure against traffic at the layer of the solution. Or maybe you don't want all of those things, you only want one of them, or potentially none of them. But if it sounds attractive to have all your metrics, logs, traces, traffic access, and quota policies, and your cert management solution all in one tool, everything in one thing, and you have the time to add it to your stack, those are all the types of features that service meshes usually provide. And so that might be a reason that you want to go towards a service mesh. But then one more little conversation here, if we're this little blue character, teal character in the middle, particularly coming from the perspective of an app developer, you might be asking yourself, first off, if your cluster admin has already provided a service mesh or installed MCS and MCG, then maybe you definitely want to use those. But you might also be asking yourself, if you're worried about there being this sidecar that is making some resource consumption or introducing some latency, particularly if you have a really specific high sensitive part of your application that you might be worried about, then you might be thinking about using something else. Or if you're in a totally different category of just there is no solution provided by your cluster admin yet for multi-cluster application discovery, that's where a project like Scupper or any other forthcoming project in this virtual application network category might be a good fit for you. So if we kind of pull together a lot of what these sort of example conversations take us through, I know the slide is kind of busy, it has a lot of stuff on it, but really it ends up being a very nuanced conversation that we can at least sort of separate into what are the decisions that are really important to the cluster admin or the platform admin, and what are the questions you're asking yourself if you're on an app dev position or app ops, if that's sort of the persona that you're coming from. And over on the cluster admin side, there's things about how Am I actually going to partition my cluster sets and my meshes? Is multi-mesh a problem for me? What is the security and observability features that the solution provides? How are these upstream projects, their trajectory potentially converging? Whereas over on the app dev side, besides just asking if you already have a solution provided to you by your cluster admin, you're asking these questions about that are application specific, like do you have a stateful app? Is it already doing its own custom traffic management or load balancing that you need to preserve? We talked a little bit about this memory and latency question, about if that's going to have an impact on some very specific part of your application or not. And so there's kind of these two sides that these questions can kind of be pulled into. Sanjeev, what do you think about this slide?
Yeah, as Laura, as you said, this is a busy slide and just illustrates that there's a lot of important factors that both the platform admin and the app developer need to take into consideration. And we encourage viewers to pause the video and go through these if that helps. But there's even more, really. I think the key point to take away is that there's a lot of enterprise-centric decisions that the admin needs to think about, such as partitioning of topologies or zero trust enterprise security policies and having the visibility. And then the app developer has an equally wide set of factors to consider, including things like if their application needs different kinds of protocols, does this technology support TCP and UDP across regions? I need to run Kafka across regions. Can these traverse firewalls if some of my clusters are behind firewalls? And if I decide that I want to roll my own solution, does the app developer team have the operational ability to fully manage its own virtual network over the top? So lots of interesting decisions, and there's definitely a lot of detail to be gone through here.
Yeah. So realistically, you're balancing a ton of factors at once. And another way that we can take a look at it is to kind of bucket some of those concerns into one of these six sort of categories that we've come up with. And then we've plotted out for these three different categories of technologies: the case native multi-cluster mesh in red, the service meshes in green, and the virtual app networks in blue. Where are their strengths really shining, and where are some of these categories that they're kind of not addressing in that specific solution? So in our experience and thinking about all of these different types of technologies, it kind of got broken down into these six categories. First off, what is the sophistication of the traffic management that you can do using this solution? What is the scope of privileges that you need to deploy this solution? What is the end-to-end scope, with pod to pod being kind of like the most control? How does this, for this solution, what level of control does it have end to end? What are the amount of security functions that you have at your disposal using this solution? What is the ease of install for this solution? How easy is it for it to both be installed and configured, really? And then what are the sophistication of the controls at the enterprise admin level? So, of course, there's tons of nuance at the level of the individual projects, the individual solutions. That's kind of simplified here. But you can see in this view that each category, when considered as a whole, sort of has its own pattern of playing to some of these strengths more than others. And depending on your situation, one of these may be a better fit than another. Sanjeev, what do you think about this?
Yes, I think this was, our attempt at sort of doing a first pass. There's clearly a lot more in terms of things like application performance, but this is a good measure of six important factors. And one can see that typically projects that have, strengths in one area may not always have strengths in the other areas. And certainly look at it both from the admin perspective and the developer perspective. And we'll hopefully get into more details over the course of these talks.
So that's it for this episode of Learn Kubernetes with Google. Thank you so much, Sanjeev, for joining me. It was awesome to collaborate on this, and we have so much more we want to show everybody in the future, but I really think that this was a great first step in terms of getting some clarity, positioning these projects, and just starting the conversation about everything that you could use for multi-cluster service networking.
Yes, thank you for having me, Laura. It was great. Yeah, really excited to work with you on further analysis of these projects.
Awesome. All right, everybody. We'll see you next time.